What we like to do is we like to review, homework review from the previous lesson. The topic was getting the area between the curves. So as you can see, we have two graphs right over here, y equals 12 minus x squared, and then the other one is y equals x squared minus 6. So what we like to do is we like to sketch these two and then find the area between them. So let's look at the first one first. I'm going to try to put the x-axis and the y-axis here. And then let us say this green one is the 12 minus x squared. All right. Now, how about how about the second graph? We're going to assume that this is -6 here and coming up, and then we're looking at those two are the intersections. So what we want to do, we want to find out this area. Now, in order for us to do that, I need to find the intersections first. So I'm going to set them equal to each other. So here we get 12 minus x squared equals x squared minus 6. Now, then I'm going to add x squared from both sides and then add up 6. So we get 18 is equal to 2x squared. So then we get x squared must be equal to 9. That tells us that x must be equal to plus or minus 3. So then I know that here must be equal to 3. And this point must be -3. Now, imagine in order for you to get the area between blue and then the green curve, you can imagine one rectangle right over here. So base would have been small x component. So we have dx is here. And then the height will be the difference between the green curve and then the blue curve. So what we end up getting is area should be equal to from -3 to +3. So green one is this one, so we get 12 minus x squared and then minus x squared minus 6 and dx. Once you solve this question, then we should be able to get the answer here. So what do we end up getting? If I have to simplify the expression first, then here we get 12 and then minus -6 becomes 18. And then negative x squared minus another x squared minus 2x squared dx. Now when you get the antiderivative of this one, you get 18x. And then minus 2x cubed over 3. Which goes from -3 through 3. So let's plug in 3 first. So when you plug in 3, what do we end up getting, guys? We get 54, 18 times 3. So we get 54. And then minus, now 2 times, so 3 to the third power is what? 27 divided by 3 becomes, yes, it becomes 9. So we get minus 18. That's what we end up getting. Minus, if you have to plug in -3, then we end up getting -54. And then when you plug in -3 in place of x here, we get -27 divided by 3 becomes -9. But we have plus 18 there. Now, then you can easily see that from the first expression, what we end up getting is 36. But the second one is -36, which adds up being 72. So 72 becomes our answer for the area. All right, let's move on to the next question. Number 15. Y equals tangent of x. So if you are to sketch that, and then we are assuming that this is based upon the radian mode, of course. Starting from 0, goes up this way, vertical asymptote, in both ways. But notice the x is going from negative pi over 3 to positive pi over 3. Now, how about the sine graph? Sine is going from here, and we realize that as x approaches pi over 2, this one becomes, we realize it becomes about right over here. This value would have been equal to 2, let us say, and then here as well. So what we can do is if you have to be pi over 3, you can easily see the pi over 3 would be somewhere around here before the intersections. Now, one of the ways for you to tell is if you plug in pi over 3, what do you end up getting? So in case of this case 2 sine of pi over 3, then we get radical 3. Oh, in fact, they might be the same place actually. Radical 3. And then if you have to plug in pi over 3 in place of x here, tangent of pi over 3 will be also equal to radical 3. So we're looking at, in fact, intersection here in both places. That's equal to pi over 3. And this must be equal to negative pi over 3. Now, first, what we're going to be doing is, due to the symmetry, we will write up the expression initially just to understand what's happening. But we will actually just calculate only one area and then double it. And of course, another intersection here must be equal to 0. So if I were to call this one as a first area and the second area here, first area becomes from negative pi over 3 rather, to 0. But what's on top? Blue one is on top. Blue one was the tangent. So tangent of x, and then minus the red one, which is minus 2 sine x dx. And then area of the second one goes from 0 to pi over 3. But what's on top? Top one is the sine, so we get 2 sine x minus the bottom one is the tangent x dx. Now, since due to the symmetry, we realize that in order for us to find the entire area, all we have to do is double this portion. So what we like to do is let's try to evaluate this one. Now, first component is rather simple. What is the integral of a sine? It will be negative cosine. So that portion is okay. So if I were to just continue, negative 2 cosine of x. How about the second one? I'm going to do that on the side, and then we're going to try to rewrite down the answers over here. So if I were to integrate negative tangent of x dx, what we can do is this one is equal to negative sine x over cosine x dx. And this is so popular expression, so if I were you, I'd try to memorize how we get them. Now, if you have to use u as cosine of x, then you know that du becomes negative sine of x here. So therefore, this can be, if you let u equals cosine of x, du equals negative sine of x, so therefore, and then dx. So this can be rewritten as 1 over u du. That means ln of absolute value of u, which becomes cosine. So we have cosine of x plus c. But since this is definite integral, we don't have to worry about plus c. So I'm just going to write down plus, because negative sign we included in integration here, plus ln of cosine of x goes from 0 through pi over 3. Now, whatever we get, don't forget we have to double it. So if you have to plug in pi over 3, what do we end up getting? Negative 2 times cosine of pi over 3 is equal to 1/2. And then plus ln of 1/2. That's what we end up getting. Now, minus. If you have to plug in 0, then we end up getting cosine of 0 equals 1. So we get negative 2. And then when you plug in 0, we get cosine of 0 equals 1. So ln of 1 becomes 0. So we get plus 0. So let us try to simplify this one. This one now becomes negative 1 plus ln of 1/2. Now, second one is plus 2. So what we end up getting is 1, because negative 2 plus 2. Now, if you look at it, I can write it as plus ln of 1/2. That's perfectly fine. But did you realize ln of 1/2 is equal to ln of 2 to the negative 1 power, which is equal to negative ln of 2. So what I can do is minus ln of 2. This operation is rather popular for you to remember. So now, what we're going to be doing is, this is the area only for one of them. Then what will be the area for both? Combined together, it will be double of that, which is 2 minus 2 ln of 2 becomes our final answer. Alrighty, let's move on to the next problem. Alright, so next one is here we have x equals. So I'm going to first try to sketch x-axis and y-axis. So it says x equals 2y squared. So then this is sideways parabola. We're facing towards the positive side. So we have one goes up this way and one goes down this way. That's x equals 2y squared. How about the second one? Second one is starts with 4, but this one is wider compared to this one. So it starts with 4. So I'm gonna go for. I'll try to go this way and this way. So we have 2 intersections here. Once again, what we need to do is we need to figure out the intersections. We will do that by setting them equal to each other. So we have 2y. 2y squared is equal to 4xl. 4 plus y squared. So when you subtract y squared, we get y squared equals 4. Hence y equals plus or minus